Okay, in this video, we're going to talk about quadratic inequalities. So now we've looked at quadratics for a little bit now, and we should know how to factor. So you're going to need to be able to factor to do this. You can use quadratic formula, but factoring is an important skill, and we'll be using it in this video. All right, so here you see an equation, a quadratic equation that we're used to seeing, and here's the graph of that equation. Okay, and now we can actually take this and we can factor this like normal. So I can factor this to x minus 3, x minus 1. And I can see that if I were to solve this, if I were to set this equal to 0 to find x-intercepts, I would get 3 and 1. And you can see that here, that my x-intercepts of my graph are 3 and 1. Okay, and this is with an equal sign. So what we want to do is we want to consider what could we be asked with an inequality sign. So we could ask x squared minus 4x plus 3. We could say, when is this graph less than 0? And we need to think about, what does less than 0 mean? Less than 0 means the y values are negative. Okay, another way to think about that is that we want to find the part of the graph that lies below the x-axis. Okay, so if we ask, when is x squared minus 4x plus 3 less than 0, we can see over here that the part that is less than 0 is this bottom part. So this bottom part is below the x-axis. And in words, we would describe that as being the part of the graph that is between x equals 1 and x equals 3. So it's between the x values 1 and 3. And so we would write that as x being between 1 and 3. Okay? And so if this is a less than, then I'm going to have less than here and here, as opposed to if this had an or equal to, I would include my or equal to with my signs. Okay? So now, what else could we be asked? We could be asked, when is x squared minus 4x plus 3 greater than 0? And greater than 0 means y values are positive. And another way to think about that is we are looking for the part of the graph that is above the x-axis. And so you can see on this graph that this part of my graph is above the x-axis. And how would we describe that? Well, here's my x-intercept, and you can see that if I look at x values, this is going and it's getting wider and wider and wider. So it's really, the x values are going this way. And as I go this way, I have a higher value. And the further I go, I'll have a higher value. So we would say that this is when x is less than 1. So when x values are less than 1, my y values are positive or above the x-axis. We can also see that this part of my graph is above the x-axis. And if we look at this, this is our x-intercept at 3. As this graph gets wider and wider, I'm moving this way. So I have an x value here that meets this y value, and I have an x value here. I have this y value. So as I go to the right, my y values get higher. And so we would say that this is also when x is greater than 3. So for x values greater than 3, my y values are positive or above the x-axis. And for x values less than 1, my y values are also positive. So I can use a comma or I can write or. So when x is less than 1 or when x is greater than 3. And then again, for up here, when x was anything between 1 and 3, my graph was below my x-axis or had negative y values. Okay, let's look at one more. So here we have a graph of y equals negative x squared plus 3x minus 2. And you see this graph, and we know based on our last lesson that because this is a negative here, this graph opens down, which you can see that. And we need to be able to factor this. So I'm going to take a negative 1 out as a greatest common factor. And then I'm going to factor further, which is going to give me x minus 2 and x minus 1. And you can see that if I then set this x minus 2 equal to 0, I get 2. And if I set this x minus 1 equal to 0, I get 1. And those are going to be my x-intercepts. Okay, you see those on the graph. That would be my answer for this one, which has an equal sign. But if I asked you, when is negative x squared plus 3x minus 2 greater than or equal to 0, we would need to know that this is asking us when are the y values positive. And another way to think of that is when is our graph above the x-axis. So if we look at this, here I'm below the x-axis. But then when I get to 1, I start becoming, so if we look at this here, I'm below the x-axis. At 1, I'm on the x-axis, and then I'm above the x-axis here. So I'm above the x-axis here. And so we would say that's between 1 and 2. So x is between, and because this has an or equal to, we're going to include those points. So x is between 1 and 2, and we're including 1 and 2 because we included it here. So when is it greater than or equal to 0? Well, it's equal to 0 at 1 and 2, and it's greater than 0 between 1 and 2. So that's what this looks like. Okay, I could also ask you, when is negative x squared plus 3x minus 2 less than or equal to 0? And remember that less than or equal to 0 means that y values are negative, or we can look at it as being when is our graph below the x-axis. And you can see, looking at your graph, that here we're below the x-axis. And so we started our x-intercept, that's 1, and we're actually moving this way. So I'm getting wider, but I'm moving left as far as the x-axis goes. So we can say when x is less than or equal to 1. And again, because this is or equal to, I'm including the or equal to here. Also, you see that this part of my graph is below the x-axis. And we started our x-intercept, but in this case, it's getting wider, and the x values are going this way. So when x is less than or equal to 1, or when x is greater than or equal to 2. So basically your answers are going to be connected like this if x is between two values, or it's going to be separated like this if x is to the left of one value and to the right of one. And it's always going to be the smallest value when x is less than or equal to the smallest value, and when x is greater than or equal to the largest value. Okay, so here's what I want you to do. I want you to take a minute and I want you to pause the video and I want you to factor this problem. And then check your answer with me. Okay, so we know how to factor, and so when you factored this, you should have gotten x minus 1 times 2x plus 5, and then we have greater than or equal to 0. So if you did not get these for your factors, then you need to go back and review factoring because you'll have to be able to do that on this test. Okay, so these are my factors. We can set this one equal to 0 and we get x equals 1. And we can set this one equal to 0 and we get negative 5 halves. So those are the two x-intercepts. Before we can do the next part where we actually answer this question, when is this graph greater than or equal to 0, we need to sketch a rough graph. We don't need anything special. We just need to know where our x-intercepts are. So I have 1 at 1, so that's approximately there, and negative 5 halves, we can say approximately there. Okay, it doesn't have to be perfect. It's just so we can see our graph. And then because of this, my graph opens up. So that's a good enough sketch for me to be able to answer this question. Okay, the question now is, when is that graph greater than or equal to 0, which is again above the x-axis, or when y values are positive? So I want you to take a minute and try to write that answer and then check your answer with mine. Okay, so we see that it's above the x-axis here. And this was our smallest x-intercept, the negative 5 halves. So when x is less than or equal to negative 5 halves, it's also above the x-axis here. And this was our 1, our x-intercept of 1. So when x is greater than or equal to 1. Okay, and that should be the answer that you have. Always the smallest x value, so x is less than or equal to the smallest, and x is greater than or equal to the largest when you have these two parts of your graph. Okay? All right, I want you to take a minute and pause the video and try to do this whole problem. So factor it, find your x-intercepts, sketch your graph, and then write your answer, okay? And then check your answer with mine. Okay, when you factor this, you should have had 5x minus 1 and 3x minus 4 is less than 0. So it's really important that you're factoring correctly. Okay, so if not, you need to go back and review. these are my factors. When I set this one equal to 0, I get 1/5, a positive 1/5. When I set this one equal to 0, I get a positive 4/3. This is the smaller one. 4/3 is a little over 1, so this one's bigger. When you sketch your graph, again, not anything special on our graph. We know that this is positive, but it's really close to 0, so it's going to be right about there. And this one is just a little bit more than 1, so we'll just say right about there. And because this is positive, my graph opens up. So that's a good enough sketch to answer this question. And then you go back and you look at this. This says, when is this graph less than 0? So below the x-axis. And in this case, you can see that it's below the x-axis between those 2 points. So we're going to write x is between. Signs will always point this way because this is x is greater than this value but less than this value. And then we're going to put our smallest here and our largest here. And that should be the answer you have. Now, here we included the or equal to because it was included here. So when we look at this, this says where is this above the x-axis? And this one includes the x-intercepts. Whereas this one says, where is it below the x-axis? And because it doesn't have an or equal to, it's not including the x-intercepts. So even though I don't always write this includes the x-intercepts, you have to keep the or equal to if it's there. Okay, I want you to take a minute and pause the video and try this whole problem. Okay, when factoring, if this has a negative in front of it, we want to take a -1 out as a greatest common factor. And now I can factor the inside. And when you factor that, you should have x minus 4, x plus 1. And then we have less than or equal to 0. Okay, so when I set this equal to 0, I get a 4 here, and when I set this equal to 0, I get a -1. So when you sketch a graph, you have a -1 here, and then an x-intercept of 4. Be careful because that's negative, so my graph opens down. And then I need to go back and look at my sign. I am asked for where is this graph less than or equal to 0. So again, that's going to be below the x-axis, but including the x-intercepts. And you can see that it's below the x-axis here. Again, that's my smallest x-intercept, that's -1. So when x is less than or equal to -1, or you can see here, when x is greater than or equal to 4. And that's my 4 for my x-intercept. So this should be the answer that you have. Okay, see how you have to be able to get the factoring correct and the solving correct to be able to get this answer correct. So it's really important. Okay, take another minute, pause the video, and try this problem. Okay, again on this one, it's negative. We need to take out a -1. And then we need to factor the inside. And when you factor the inside here, you get x minus 5 and x plus 3. You could always multiply this back out to check to make sure that you have what you started with. Okay, but it's important that you can get the factoring correct. This is going to give me 5 when I set it equal to 0 and solve. And this one is going to give me -3. Now I can sketch a graph. I have a -3 as one x-intercept. And my other one is 5. Because this is negative, my graph opens down. So that's a rough sketch. Now we're looking at this, and this is asking us where's the graph greater than 0 or above the x-axis. And this time there's no or equal to, so we're not including our x-intercepts. Our answer would be, we need to find this. So we need to find this part on the graph. You can see that this part, this top part, between those two values is the part that's above the x-axis. So when x is between, but not including, so just between, -3, the smallest one always goes here, and 5, the largest one always goes there. Okay, so that's your answer. Okay, take another minute and try this one, and then check your answer with me. Okay, so you're factoring. You should have an x minus 6 as one of your parentheses and x minus 2 as the other one is less than or equal to 0. This one, when we set equal to 0, is going to give us 6, and this one is going to give us +2. So on a sketch, we're going to have 2 here and 6 maybe over here. And we look here, it's positive, so our graph is going to open up. Now we're asked, where is it less than or equal to 0? So below the x-axis, and again, this one's including the x-intercepts. And so it's below the x-axis here in the middle of my graph between these two. So when x is between and including, that's the or equal to 2 and 6. So when x is between 2 and 6, but including those points. Okay, take a minute, pause the video, and try this problem. Okay, since this is a negative, we need to take out a negative 1, which is going to give us x squared minus 15x plus 50. Now I need to factor the inside, and that is going to give us x minus 5 and x minus 10. So when I set x minus 5 equal to 0 and solve and move the 5 over, I get positive 5. And when I set x minus 10 equal to 0 and solve, I get positive 10. So my graph is going to look like this. Let's say 5 is here and 10 is here. This is negative, so my graph opens down. Okay, this is my graph, and then I want to find where is the graph above the x-axis, or where are my y values positive. And you can see that that part is also in the middle, just like this graph was, but this graph opens down and it's above the x-axis, the middle part. So when x is between, the smallest one goes here, and the largest one goes on the right. So when x is between 5 and 10, and in this case, we're not including the 5 or the 10. Okay, we just have 2 more problems to look at, and these are special cases that can happen. So this is where you just really got to pay attention to what you're asked for. So I need to factor this one first. When I factor this, I get x minus 2 times x minus 2 is greater than or equal to 0. You might also see this written as x minus 2 squared, since those are the same. Okay, so either way you want to write it, or if you see it in different ways, know that this is the same. So in this case, if I were to set either of these factors equal to 0, I would just get 2 for both of them. So that means the only x-intercept on my graph is 2. That's the only x-intercept. So I can't hit the x-axis or cross the x-axis at any other point, which means this has to be my vertex. So my graph is going to look basically like that because it opens up. Okay, so it opens up, which is why I drew it that way. And that's the only x-intercept too. So now you have to look at your question. Your question is, when is this graph greater than or equal to 0? So above the x-axis, including the x-intercept. Well, if you look at this, here's my x-axis. We're going to include the x-intercept. And the other question is, where is it above the x-axis? Well, it's always above the x-axis. So we would say for all values of x. So for all values of x, it is either greater than 0 or equal to 0. It's equal to 0 at the x-intercept, and it's greater than 0 for all other values. Okay? Okay, I want you to take a minute and try this one. Factor it out, sketch a graph, see if you can come up with an answer, and then come back and check your answer with mine. Okay, when we factor this one, we get x plus 3 times x plus 3, and we want to know when is it less than 0. We could also write this as x plus 3 squared is less than 0, either way. But because these are the same, we're only going to get one x-intercept, which is going to be negative 3. So negative 3 is my only x-intercept. I need to look at this and my graph opens up. So if that's my only x-intercept and my graph opens up, then that has to be my vertex. And this is really completed square form without the, instead of an equal sign, we have a less than. Okay, but this is what my graph looks like. So the question now was, when is this graph less than 0? When is this graph below the x-axis? Look at this. When is it below the x-axis? It's never below the x-axis. And since this doesn't have an or equal to, we can't even include this x-intercept. So we would say, for no values of x, there are no values of x where this graph is less than 0. Now, There's one value of x where it's equal to 0. So if I had included that or equal to right there, I would have had to say at -3 only. But in this case, since we're not including that point on my x-axis, there's no values of x where this graph is below the x-intercept. Okay, so those are just things you run into and you need to stop and think about what you're being asked. Okay, go back and review what you need to, and we'll continue in class.